The Kuiper belt, home to Pluto and other dwarf planets. Title: The Kuiper belt, home to Pluto and other dwarf planets. Introduction. Nestled at the fringes of our solar system lies the Kuiper belt, an extensive region filled with icy objects, including dwarf planets like Pluto. This distant neighborhood, named after astronomer G. Rard Kuiper, has continually fascinated scientists, offering valuable insights into the formation and evolution of our cosmic neighborhood. In this article, we'll delve into the intriguing world of the Kuiper belt and explore the numerous dwarf planets that call it home. Unveiling the Kuiper belt. The Kuiper belt resides beyond Neptune's orbit, between roughly 30 and 55 astronomical units, from the Sun. Spanning a vast area of space, this region contains millions of icy bodies, primarily composed of volatile materials such as water, methane, and ammonia. Although individual objects within the Kuiper belt can range in size, dwarf planets stand out as some of the most captivating reside. NTS. Pluto, once a planet, now a dwarf. Our journey through the Kuiper belt naturally begins with the enigmatic Pluto. Pluto's unusual orbit, tilted and eccentric, distinguishes it from the 8 classical planets. Its highly elliptical path periodically brings Pluto closer to the Sun than Neptune. Additionally, its atmosphere, composed primarily of nitrogen, methane, and carbon monoxide, undergoes seasonal variations due to its elongated journey around the Sun. Pluto's 5 known moons, including Charon, its largest companion, add to the intriguing dynamics of this dwarf planet. Other fascinating dwarf planets. While Pluto may be the most famous of the Kuiper belt inhabitants, several other dwarf planets share its home. These celestial objects offer additional insights into the composition and formation processes within this distant region. 1. Eris. Almost the same size as Pluto, Eris gained notoriety when its discovery in 2005 sparked the debate that ultimately led to Pluto's reclassification. Eris orbits the Sun in an elongated, Y-inclined path, making it one of the most distant known dwarf planets. 2. Makemake. Similar in size to Pluto and Eris, Makemake is a distant world characterized by its reddish hue. Its surface is likely composed of frozen methane, ethane, and nitrogen. Makemake's orbit presents interesting characteristics, including a relatively large inclination and moderate eccentricity. 3. Haumea. This elongated dwarf planet showcases an intriguing shape, resembling a flattened rugby ball. Haumea spins rapidly, completing a full rotation in just under 4 hours. This rotation results in its unique elongated form and an equatorial ridge. 4. Ceres. Located in the asteroid belt between Mars and Jupiter, Ceres is also classified as a dwarf planet. Its distinction lies in being one of the most massive objects in the asteroid belt, comprising over 1/3 of the belt's total mass. Ceres provides valuable insights into the early stages of planetary formation. Formation and origins. Understanding the formation and dynamics of the Kuiper belt and its dwarf planets unveils crucial information about the early solar system. The prevailing theory suggests that Kuiper belt objects met closer to the Sun and migrated outward due to gravitational interactions. These icy bodies may have emerged from the same primordial material that gave rise to the gas giants, such as Jupiter and Saturn. Further exploration and future missions. Our knowledge of the Kuiper belt and its dwarf planets has expanded significantly over the past few decades, primarily due to advancements in space exploration. The New Horizons mission, launched by NASA in 2006, carried out a flyby of Pluto in 2015, capturing detailed images and data from this distant world. Future missions, such as NASA's Lucy and Europa Clipper, will continue to explore and study other dwarf planets and icy bodies within the Kuiper belt. Researching and studying the Kuiper belt and its many dwarf planets has been an ongoing endeavor for scientists. The Kuiper belt is a vast region situated beyond Neptune's orbit, approximately 32.55 astronomical units away from the Sun. This region is teeming with millions of icy objects, mainly composed of volatile substances like water, methane, and ammonia. However, it is the dwarf planets that capture our attention the most. The journey through the Kuiper belt begins with Pluto, the once ninth planet of our solar system. It orbits the Sun in an eccentric and tilted path, occasionally crossing paths with Neptune. Pluto's atmosphere, consisting predominantly of nitrogen, methane, and carbon monoxide, experiences seasonal variations due to its elongated orbit. Additionally, Pluto has 5 known moons, with Charon being its largest companion, adding to the fascination surrounding this dwarf planet. While Pluto stands as the most well-known inhabitant of the Kuiper belt, other dwarf planets inhabit the region as well, each offering unique insights. Eris, discovered in 2005, is almost the same Z as Pluto and played a significant role in the debate that resulted in Pluto's reclassification. Eris has an elongated and highly inclined orbit, making it one of the most remote known dwarf planets. Makemake is another dwarf planet of similar size, characterized by its reddish color. Its surface likely consists of frozen methane, ethane, and nitrogen. Haumea, on the other hand, is an elongate dwarf planet with an intriguing rugby ball-shaped appearance. Its rapid rotation completes a full cycle in under 4 hours, causing its distinctive shape and an equatorial ridge. One dwarf planet that deserves special mention is Ceres, which is located in the asteroid belt between Mars and Jupiter. Ceres is unique because, along with being classified as a dwarf planet, it is also one of the most substantial objects in the asteroid belt, accounting for over a third of its total mass. Ceres offers valuable insights into the early stages of planetary formation. Understanding the formation and origins of the Kuiper belt and its dwarf planets provides essential information about the early solar system. According to the prevailing theory, Kuiper belt objects formed closer to the Sun and migrated outward due to gravitational forces. It is possible that these icy bodies emerged from the same protoplanetary material responsible for the formation of gas giants like Jupiter and Saturn. Advancements in space exploration have significantly expanded our knowledge of the Kuiper belt and its dwarf planets. The NASA mission, New Horizons, launched in 2006, conducted a historic flyby of Pluto in 2015, capturing detailed images and data from this distant world. The research and study of the Kuiper belt and its multitude of dwarf planets have been ongoing for scientists. The Kuiper belt is situated beyond Neptune's orbit, approximately 30 to 55 astronomical units away from the Sun. It is a vast expanse filled with millions of icy objects primarily composed of volatile substances like water, methane, and ammonia. However, it is the dwarf planets that capture our utmost attention. The journey through the Kuiper belt commences with Pluto, once known as the ninth planet of our solar system. It possesses an eccentric and tilted orbit, occasionally intersecting with Neptune's path. The atmosphere of Pluto, primarily consisting of nitrogen, methane, and carbon monoxide, experiences seasonal fluctuations due to its elongated orbit. Furthermore, 5 moons have been discovered around Pluto, with Charon as its most prominent satellite, further adding to the fascination surrounding this dwarf planet. While Pluto emerges as the most renowned inhabitant of the Kuiper belt, other dwarf planets also reside within the region, each offering distinctive insights. Eris, discovered in 2005, is almost equivalent in size to Pluto and played a crucial role in the debate leading to Pluto's reclassification. It maintains an elongated and highly inclined orbit, making it one of the most distant known dwarf planets. Makemake, another dwarf planet of similar magnitude, displays a reddish hue. Its surface presumably comprises frozen methane, ethane, and nitrogen. Haumea, on the other hand, manifests as a